This video is going to look at what happens when we look at the limits at infinity. And looking at the function f of x equals 1 over x, we have the graph here. We know that there's going to be a split in the graph at 0 because the denominator cannot be equal to 0. We would have 1 over 0, which is undefined. So our graph is going to split. And what we want to look at now is we're going back to looking at limits. And if we take the limit here of 1 over x as x goes to infinity, well, if x is going to infinity, then that means what's happening as x gets extremely large? Well, as x gets extremely large, our graph is getting closer and closer to the x-axis. And you can tell with the graph, the further this goes out, the closer it's going to get. But we know that it will never get to 0 because 1 over x can never equal 0. So therefore, if we look at the limit though, as this goes to infinity, we can think of this as being 1 over infinity. And if we have 1 over a very large number, what's going to happen? For example, if you think of having 1 over 10, and then 1 over 100, 1 over 1,000, 1 over 10,000. As this denominator gets bigger and bigger, what's happening to your number? Your number is getting extremely small. So if we have 1 over a really large number like infinity, then that tells us our limit is going to approach 0. Okay, and I think you can see clearly if this graph continues out, it's getting so close it is becoming 0. And the same thing is going to be true if we look at the limit of 1 over x as x approaches negative infinity. Well, that just means we're going to the left. So if we go to the left once again, we can see that our graph here is getting ever so close to the x-axis. So therefore, once again, if we have 1 divided by negative infinity, again, the negative sign really doesn't affect the problem here because it's 1 over a very large number here. So again, that's going to go to 0. So basically, anytime you have infinity in the denominator, where the denominator is growing very, very fast, your limit is going to go to 0. And graphically, you can see that here, that as this graph continues to the far right and to the far left, you would be approaching 0. And you'll notice what this indicates here is when your graph here is going to infinity and you end up with, in this case, 0, that's telling us that we're going to have a horizontal asymptote. Okay, so here you would have a horizontal asymptote at y equals 0 because that's what our limit was for as x approaches infinity or negative infinity. That's telling us if we're going to infinity here and we're approaching 0, that tells us that the horizontal asymptote would be y equals 0. All right, let's look at a couple more examples here and see if you can figure these out. If we look at the limit of 3 over x, well, if we kind of think of using direct substitution, that means we would have 3 over infinity. And again, it doesn't matter that this is a 3 because we have 3 over a very large number. And 3 over a very large number, again, the denominator is getting huge, so we're going to approach 0. All right, the next example, what do you think is going to happen if we look at the limit of 1 over x squared? Well, because we square the denominator, well, that means we would have 1 over, well, infinity squared is still just going to be infinity. It's just actually going to go to 0 at a much faster rate. So 1 over infinity squared is infinity. So again, we have 0 as our limit. And once again, what that tells us is you're going to have a horizontal asymptote for each one of these your horizontal asymptote would be y equals 0 and y equals 0. All right, see if you can answer this next one. What's the limit of 2 as x goes to infinity? Now be careful, if you said 0, you kind of fell into my trap here. This is the limit of 2. This is a constant. There is no x here. So here, your limit is still 2 because it doesn't matter what x approaches. Keep in mind here, this is a constant function. So here's the graph of y equals 2. So notice it doesn't matter what happens to your x value. Our x value can go to infinity, but our graph up here is always 2. So it doesn't matter. Okay, so again, if your denominator is going to infinity, that means it's growing very rapidly. So therefore, you're going to approach 0. You're getting to a very, very small number.